All right, so this week we're going to start talking about object-oriented programming and design. And we're going to extend, I'm going to give you a little chance to practice what you learned about player prefs last week by implementing player prefs in your number guessing game. So you'll get a chance to apply your newly acquired knowledge. All right. All right. I'm not the sharpest tool this morning. All right. We'll go ahead and talk about the number guessing game, right? I'll share my screen here. Everybody see that?
Yeah. Yeah.
All right. So, basically, you have your number guessing game from last semester, or 113 if you didn't take it last semester. But what I want you to do is use player prefs to create a best score, right? So in this case, it would be the lowest number of guesses, right? And that should be saved between sessions so that, you know, however many times you play the game, you can see your best score to date, right? And I might, before the end of class, I'll probably go through some of this to show you kind of what I'm thinking about. But I want you to try your hand at it before Wednesday. That way, if you have questions, I can really kind of delve into your questions then. I want to see what you can do without me hand-holding you too much on that. So I'll leave it at that right now. All right, so as far as last week's video, I didn't post it because right after class was over, I stopped the recording and I left the room. And when I came back, my computer had crashed and restarted, and that whole recording was lost. So, and I didn't feel like redoing it. So, if anybody has any questions about that or needs me to actually redo all that, let me know. But I don't think any of you do because you've turned in the assignment. So, and the people who aren't here haven't responded to me, so I'm not going to worry about them if they're not worried about me. All right. So let's talk about object-oriented programming. OOP. Well, it's usually OOD or OOP. They kind of go hand in hand, right? Has anybody ever heard of object-oriented programming before? Anybody? All right, well, I'll take that as a no. All right. Object-oriented design. Object-oriented what object-oriented programming is is a way of programs used to be this kind of a linear task, right? You would your programs would kind of start at the beginning and say, well, we're going to do this and do that, and it would go from one instruction to the next, and it was very procedurally based, and that's what they would call it, procedural programming, right? So that one thing followed another until the end, right? But that was very hard to maintain, right? So you program it, and then you have to make changes to it, and small changes would cause big changes down the line, right? And it was hard to visualize. As computers gained more power, it became important that programs and the design of programs become more visual and more conceptual, right? And this is where object-oriented design comes in, right? If you'll look at our page here, right? This link here, if you click on that, right, it'll take you to this page. So, what object-oriented programming and design allows us to do, right? Allows us to think of software design in conceptual, abstract terms. Right. Now, I always get into this point here. When I say abstract, what do y'all think of as abstract? Where have you heard that term before?
In paintings.
In paintings, yes. And when you think of abstract art, what do you think of?
Distorted, not clear.
What's the opposite of abstract? In art terms. Who's an artist out there? I know we got at least one, right? I think. None of y'all identify as artists. You're all programmers. All right. So what's the opposite of abstract art? All right, well, y'all are feeling as talkative as me, I guess. Well, that would be kind of representational art, right? Stuff that when you look at it, you can tell what that is, right? So, in art terms, abstract is the odd thing, the thing that doesn't appear to look like what it is, right? In computer terms, it's kind of backwards. Abstraction seems to be the opposite of what we think of art, right? Because what language do computers speak?
Binary.
That's right. It's binary. And what is that?
Ones and zeros.
Ones and zeros. All right. So, in computer terms, right, ones and zeros, they are representational, right? They are that is actually what computers speak, right? That is the real thing, right? Everything else to a computer, is abstraction, right? So when I go up here and click this menu, right? See how I did that? Well, see, I didn't actually click on a menu. I clicked on a mouse that sent a message to the computer that I was in this general area here, right? Or like, in fact, mousing over that sends a message. It sends a message to another thing, right? To the computer, it's all ones and zeros, right? What we see here is actually the abstraction, right? So to us, the abstraction when it comes to computers is the thing that makes sense. It's almost backwards from art. So you should understand that. And that object-oriented design allows us to speak in abstract terms to describe things that the computer only knows in ones and zeros. Right? So we can talk in terms of concepts instead of, well, we need to create an integer here that's so long or whatever. You don't have to talk you can talk in general terms about the concepts that your program's going to be implementing without getting into the details of how to implement that. Does that make sense? So object-oriented design allows us to think in general abstract concepts as opposed to the specifics of code. And that's a big deal because when you create really large systems, you don't want to start just diving in and creating code, right? You want to think about how the system is designed in abstract terms in these kind of pretty pictures. You draw flowcharts and all. Flowcharts being one of the is an object-oriented design principle, actually. And there's all sorts of visual ways of showing object-oriented design, and we'll see some of them shortly. All right. So if we go to that page that I showed you, right? So object-oriented programming, right? If you search for object-oriented programming, object-oriented design in Google, you'll find all sorts of different pages about it, right? And I encourage you to do that because everybody has their own take on how they present it, right? And some of them may make more sense to you, maybe even more than what I'm saying here. And this author's pretty good, in my opinion. But he says object-oriented programming is a concept used by programmers to develop fully independent units of code. That independence is important, and we'll get to that in a little bit. But each unit is known as an object. And what is an object? Well, an object is basically anything, right? What is an object? It can be anything, right? Anything that you can conceive of in a game can be considered an object, right? Name something in a game that you could think of as an object. Anybody?
A weapon?
A weapon, yes, very good. Weapon. And let's see. Jacob said a door. Yep. What else? A chair. Katie, chair. Charles says an NPC. That's very good. Those are all very good things. Yes. I think we've used this before, but I mean, the thing is, even invisible things that are existing in the game, right, can be considered objects, like a game manager, right? That's in the game, but you don't see it, right? But it's still an object. Objects don't have to be visible. So obviously a PC, a player character, would be one, right? A spell, right? Let's see. Enemy, right? There's any game with any complexity could have hundreds to thousands of objects in it. Right? The thing to note here is that we are conceiving. These are just concepts, right? And we can conceptualize these without having to worry about how they're coded necessarily, right? And that's what the purpose of this week is to get your mind wrapped around the fact that when you start on a large project, you don't want to just dive in necessarily and start coding it, right? You want to put some time into the actual design of how these objects relate to one another, right? Because if you do that correctly, then your code will be more efficient and less error prone, right? So what are the benefits of object-oriented programming? So here, what are objects? Right, and he says an object is something that has properties and methods, right? He kind of gets into the coding side of it right on. But this is he's really covering object-oriented programming, whereas that's an extension of the design, right? So he's kind of diving into the programming part, which is fine. All right. I'll copy that there. When we think of that, an object has something with properties and methods, right? Think of this as properties and methods as nouns and verbs, right? Nouns are things that describe properties of the object, right? Verbs tell what the object can do, right? All right. So we all know that nouns are people, places, and things, right? And verbs are action words, right? They say, they tell what things are doing, right? They describe an action. And properties and methods should be considered very much that. And when you describe them, you should use those parts of speech for very obvious for reasons that are obvious once you become a programmer, right? You always want your code to read as much like natural language as possible. So if you use nouns for your properties and verbs for your methods, your code will read better. All right, so let's take one of these obvious things like here, like a PC, a player character, right? Actually, we'll say PC. Player character, for those that don't know what that is, but you should. All right. What are some properties of a player character? What would some properties be?
Movement.
Movement. When you say movement, what do you mean?
Having a first-person controller or a third-person controller, something like that. The ability to input movement from a keyboard, from a controller.
So, in terms of a noun, what's something we could? I mean, movement is a noun, but it. What? Let me try to think. What does that really? Is there something more specific we could use that would be clearer as to what we're actually looking at?
Input.
Input. So you're thinking very specifically on how the user is going to move the character, right? I'm thinking when we're talking about the player character itself, right? We are thinking this is the abstraction, right? The player character in the game, it doesn't know it's being moved by you, right? Does that make sense?
Yeah.
It is its own, and that's part of the whole object-oriented thing, is that it is its own kind of entity, right? And it how it's moved it doesn't matter to him how it's moved, right? But he does have movement speed, right? And that's probably what I would put in there, right? How fast he knows how fast he can move. He doesn't know that you're controlling him. So that's the kind of properties we're looking for. Yes, there could be and there is a player controller, right? And that's a separate script and a separate object that actually kind of oversees the player and moves them around. And they can be all meshed into one. But one thing you should know is object-oriented design and programming, that it's both a science and an art, right? And there's never one right answer when you come to how objects are created and designed and put together and interact, right? So just because I say it, don't make it so. These are just my thoughts, right? But so movement speed, I would say, would be a good property. What's another property of a player character? Anybody play D&D? Dungeons and Dragons?
Like attributes or like their dialogue, like how the character reacts to situations. Like personality wise.
Okay, that's very kind of nebulous. Can you nail that down into
Okay, like maybe their personality.
personality? All right, personality. All right, kind of a broad thing, but I'll take that, right? Because you know, so is anybody stats? It's stats. Yes, that's very good, right? If you play anybody play Dungeons and Dragons? Anybody played Skyrim? Skyrim. Yep, of course, right? The character creation sheet, right? What do you have on that sheet? That's what we're talking about here, right? What? So name a stat. Strength. There we go. Right. See, now we're talking. These are the things that these are the base core things, right? That every role playing game has these stats, right? XP, right? HP, dexterity, right? Personality, you'll see alignment, right? Because personality is kind of a broad term. Alignment, the evil good, neutral good, that kind of thing, right? Neutral evil, right? Personality, there might be something in a game about that, but usually the alignment's more kind of what you're looking for, right? Dexterity, strength. What's another one? Constitution, right? Charisma, yes, right. So, And there's a bunch of others, right? Look up D&D character sheet, and you can see everything. There are tons of examples, right? D&D character sheet. Right. That's incredible. There we go. All right. Strength, dexterity, constitution, intelligence, wisdom, charisma. Right. This is a pretty good example of a PC object, right? A player character object. All the different things they can do, right? I mean, the properties and the things they can do, which we haven't got to yet. All right, so that's a good example of properties, right? So methods, right? Verbs, actions. What are some things that a player character can do? Attack, very good. Note that that is actually a verb, right? You want your methods to be verbs, right? Because that way, when you read your code, right, in your code you might have my PC, and that could be actual code and type of attack, right, and target, right. This is pseudocode, but it could read just like that, right? And that way, it's very clear what you want them to do, right? You say my PC, you want them to attack, right? And then the type of attack and the target, right? I mean, that is clear. I think to anybody with a passing knowledge of programming can probably figure out what that's trying to do, right? All right, so attack is one. What's something else? Defend. Yes, we can say defend, yes. Run, jump, yes. Run, jump, pick up. All those are good, yes. And there's note those are all actually verbs, right? Heal, yes. So when you do the assignment for tonight, right, or this week, my biggest thing that I'm looking for, right, is that your properties are actually nouns, right, and that your methods are actually verbs, right. I know it sounds like it's an English class, but programming in C#, they are languages, right, and you want them to read as easily as possible when you read your code. Because the compiler doesn't care what words you use, right? As long as you use them in the correct syntax, the compiler will compile your code and it'll run just fine, right? We write code so that we can read it, and so that our co-workers can read it so that it makes sense, right? So you want to make sure that you use nouns for your properties and verbs for your methods, right? All right, so realizing that at this point you don't have to know what these methods do or how they're written, right? You just know that these are the things you need this object to do, right? And that's why we do this, right? So the first thing you do is lay out what properties does this thing need and what does it need to do, right? And later on, when you actually start coding it, you have to go in and actually make them do these things, right? You fill in the blanks, right? But to start with, you start defining your objects and the connections between them, right? So let's look at, here we go. This is the assignment, one of your assignments for the week, right? This is the easy assignment. The other one might cause you a little more problem. We'll see. All right. So after this discussion that we're having right now, you'll create a drawing using Google Drawing that shows 3 objects. So three objects you might find in a game. Let's not use player character because we just did that, right? So something other than player character. Under the name of the object, list the attributes and methods of that object. Be as thorough as possible. Once complete, share the drawing with me as well as copy a link to the drawing here in the submission text. I'm going to show you basically how I want this to look, right? So let's go here, nope there, nope, not there. And I'll go in here. So Google more drawings, right? Create share. All right. And I'll call this OOD example. Actually, you should name it first and name it last name, first initial, right? OOD. Well, you don't have to call it example if you don't want to, but that's up to you. All right. So when I say I want a drawing, I don't want. This isn't an art project, right? This is a diagram project. So we're going to insert a shape, and we will insert. Let's see. Go down here, and we'll just do that. All right. Best thing to do is to format one of these, and then you can copy it, right? And the alignment left and top is probably what you want to do, right? So let's just say car, right? That's our object. And we'll put properties. I'm going to crank this down a little bit there. All right. Methods. Right. The properties, what's the property of a car? Instead of personality. Well, I'm answering Charles. So instead of personality, rather use a moral meter. Would that be better? I mean, it could be a meter, yes. I mean, personality is just. I mean, I'm not saying you can't use personality, right? You just have to find a way of quantifying that. Programs don't work well with unquantifiable stuff, so that personality is very vague. If that makes sense. I mean, how are you going to define that, and how is the computer going to deal with personality? I mean, if you have a way of defining that, that's cool, and quantifying it. The alignment has more of a way of there's a certain number of alignments. You can quantify them and detail what they are, right? So that makes more sense. And yeah, I mean, there are moral meters where it's like KOTOR, right? You're going, you're either light side or dark side or somewhere in that continuum, right? And everything you does pulls you one way or the other, right? So yeah, a moral meter would it's more quantifiable, yes. The thing is that you want to be quantifiable, right? And when it comes to programming, anything that's not quantifiable comes kind of vague and hard to program. It doesn't mean you don't put it in there, but you have to put thought into that. Anyway, car. What's the property of a car? Yes, driving speed. Yes. What's something else?
Acceleration speed.
Acceleration. Yeah. Who'd have thought that Brian would be chiming in on the car thing? All right. I didn't think about that when I put car up there, but now, yeah. All right. Wheel. What is wheel? Wheel, is that a property of the car? The steering wheel or the wheels? You mean the actual wheels? Radio. What you're actually describing there, right? And this is object-oriented programming gets very detailed, right? There are some objects that are actually aggregations of other objects, right? And a car is one of those things, right? A car isn't just a car. There's all these different parts in it. Each one of those parts could be considered an object into itself, right? And that is what we call, in object-oriented terms, an aggregation, right? We put all these parts come together and they make a whole, right? In this case, I would consider a radio and a wheel actually separate objects that combine to make up the car, as opposed to being properties of the car. Does that make sense? And I understand if it doesn't right now. Yes. I would highly suggest reading this, right? All right. Let's see. So property, let me read what he's got here and see if it's jives with my vision of property. Like I said, if you Google object-oriented programming and design primers, you will find all sorts of stuff, and they'll all kind of come at a different direction, right? So let's see what he says, right? A property in ordinary terms is anything that describes an object. Think of a color. Color would be cool for a car, right? They definitely have a color. Think of size. Yep. Look at the cars again. You will see there are big cars and small cars. There are new cars and old cars. So an age of the car, right? So I'm going to pull this over here. That's not it right there. There we go. All right. Age, right? Color, and let's see what else is it. The number of gears, the transmission type, right? Some cars have more horsepower. Horsepower would be one. In a programming environment, the same basic rule applies. Each object is different. Each button has different text written on it. Some buttons might differ in size. Some variables have a larger capacity than others. Some variables only can store strings, whereas some variables only can hold a true or false value. All right. Let's see. All right. So so those are several properties of a car, right? So it gets a transmission type. Right? All right. So what are some things that a car can do? What's the first thing it can do? The most important thing. Stop.
Yeah.
Go.
I was going to say move.
Move. I think move is more general and better at describing what it actually does, right? But I would put stop in there, right? Move and stop, right? What else? There's one other thing that's key to it, right? To getting where you're going to go. Is it everywhere you want to go straight ahead? Probably not. Turn. There we go. All right, thank you. And one thing this is just standard kind of when you're doing this, right? It's kind of to indicate that you know that you're eventually going to be programming. We do this, right? It shows that there are actually going to be methods, right? And by putting the parentheses after them. Of course, there are programming languages that don't use parentheses like that, but the one we're using, and all of the C languages do use parentheses, and many of the others as well. But so we put the parentheses after them just to kind of indicate that we know that they're methods. And note that these are all actually verbs: move, stop, turn, right? You should, as you're creating these methods names, try to make sure that, is this a verb, right? Ask yourself, is this a verb? If it's not, then change it to be a verb, right? It will help your coding be cleaner and more readable. And I will, in this exercise, I probably won't grade off if you don't do it that way, but I will comment on it. And in future exercises, it will be graded off. But this is the first time you're doing this, so I'm not going to be too hard-ass. All right. Is there anything? Move, stop, turn. That's primarily what cars do. Are there anything else that you can think of that a car might need to do? Signal. Hey, I was just thinking that. I was hoping, yes, signal. Maybe honk, right? Beyond that, I'm trying to think if there's anything else that you could possibly do. I mean, those are the main ones, right? And I want you to make these as detailed as possible, but depending on the objects you choose, there may or may not be a lot of. There are some objects that don't do much, right? If you choose like a boulder, right? Boulders don't do a whole lot. They just kind of sit there, right? That's a nice boulder. They gather moss, right? And if they, in the right situation, they might roll, right? But other than that, pretty much boulders just sit there. So try to come up with objects that actually that do more, right? And that way your diagram will look. Don't give me boulder, rock, and I don't know what's something else. Tree, I guess. Give me some things that actually have some might have some verbs associated with them. Anyway, so that's one that would be 1/3 of your assignment right there, right? So because this is already formatted the way I need it, you can just copy it. I can say Command C, right, and Command V. Oh, sorry, got to pull out of here like that. All right, Command. There we go. All right, and now I can just come in here and whatever that is, and I can delete those and delete those. All right. So now you have like a template, right? So do that, So you have 1, 2, 3 objects with properties and methods. All right, is that clear? So I don't want you drawing me pictures. I've had some confusion in the past because I said I wanted a drawing that they actually drew me pictures of these objects and didn't do what I've asked them to do here, right? The thing is, this will lead to another object-oriented assignment next week. So make sure you do it this way instead of drawing me pictures, because otherwise you'll have to go back and fix it. Right? All right. So that is the object-oriented design portion, right? So where's that? Sometimes that gets in the way. All right. All right, so 3 objects you might find in a game, right? So if you played a game or two, which I'm sure you all have, right? Come up with some objects that you've seen in games, preferably ones that have actions that they can perform. One of them can be a boulder if you want it to be, right? But, don't make them all as limited as that. All right, so that's that assignment there, right? Since you all finished the player prefs from last week, does anybody have any worries about being able to implement player prefs in their number guessing game? Any worries there? Any questions as to how that would be done? So you don't know where your number guessing game is. Was it on a computer did you have it at school as well? Is there a copy there? I can try to remember if it's even there. Trying to remember which machine you were on. I mean, I can look for it if you can.
It was on the the right side of the room. It was on the first row, all the way down in the corner.
On the right side. Right side is the way I'm viewing it when I'm sitting at my desk.
Yeah, when you're sitting on your desk, you look straight down. It'll be like the first row on your left.
On the wall?
All the way down.
The middle row or on the middle row?
Middle row, yeah. I was talking about like when you walk in the door.
Okay.
Yeah, gotcha. It's the computer all the way at the end in the middle row.
Okay, so by the window. Near the window?
Yeah. Sorry.
Yeah, I could try to find it and send it to you if I can find it.
That'd be much appreciated.
Of course, that won't be till after Wednesday, but what you could do is try to figure out the player pref part before you even get the game back, and do it that way, right? If you can implement how to save the score without the game, right? You could add it later. All right, and I might do that in a minute. All right, so let's see. Should I do this now? Let me see. Why not? I will do a little bit of this right now. So. I'm going to fire up Unity here. Okay, so I don't have a recent number guessing game, right? So what I'm going to do is I'm going to kind of mock up just the saving of the score and show you how I would do that, right? So I'm going to say new. And let's see. I'll do that. It's 2D. Ribbons. The number guess player prefs, right? And I'll put that in would create that. Because what I'm going to do here is show you kind of how I would handle player prefs slightly different than what the book showed you, right? Because what the book did was every time a high score was recorded, even shown, it would access player prefs to pull that data out. I typically prefer not to do it that way, right? I only access player prefs when the game launches. I load in the player prefs into like global variables, right? And I will alter those global variables during the game, and then when I need to save something, then I'll push them back out and save them to player prefs, right? So we'll see how to do that in a second. This import process is killer, right? All right. Okay, so I don't have a number guessing game handy, so I'm not going to recreate that right now. So what I'm going to do is I'm going to create a system where I can just enter a new score. It will compare it to the best score, right? And if it's better, it will replace the best score with the new one, right? All right, so to do that, I need a UI text, right? And I'll name that best score text, right? I will get that out of the way. Right. And I will center. Make this 28. All right. Let's see. So I need a input value or input field because I'm actually going to be. And if you want to follow along on this, I would suggest doing this in a separate project, right? Because you won't be doing this in your game. I'm showing you how I'm kind of mocking up a best score thing, right? So this will be where I input a score, right? And then I'm going to have a UI button to actually I'll just okay. Let's see. So let's go to project here. Go ahead and create a scripts folder. All this is being recorded, so I'm gonna kind of go quickly through this so that I can show you what to do. Right. Then I'm gonna create. We're gonna have a game manager because we haven't been doing that, right? So game manager, right? and we'll create a empty game object called unsurprisingly game manager, right? And because I'm smart, I'm gonna put that at the top, and I'm gonna put my game manager script on there. That. And then I'm going to open up my C# project the correct way by going to Assets, Open C# Project. And we wait for that to open. One of these two. All right. All right. View, design. We'll open up Game Manager. All right. So we have Game Manager script. I am going to go over here, right? I've created this folder. You should have access to this, right? I am going to now stop. All right, so now you should have access to this, right? Remember, you can open it with any file notepad. And now you can access it anytime through that, even if I'm not currently on my code screen, right? Now I'll try to update this. If I forget to update it, let me know so that everybody can keep up with me, right? It's taking forever. All right, there it is. Okay, back. All right, so what do we need here? Just some kind of basic setup stuff, right? We need to be able to access that field. We need a function to handle the button, right? And then we can access the high score and all that stuff. So first we're going to just come in here and say, we need to using Unity engine.ui, right? And then we want to have text public text dot best score text, right? Then we need public what is it, input field, right? Score input, right? And then we're going to create a stub function here called public void handle submit button. And we'll say debug. All right, debug log. If I could type, it is Monday, isn't it? Jesus. All right. All right, so we haven't even got the player prefs yet, right? Obviously. So what do we need to do now? All right, so we have that. Let's just connect these. Got best score text there, right? And score input there, right? I'm gonna name that. Right. All right. So now when we click the button, we should be able to call that function, right? So we're going to go to the button and come over here. List is empty. So we need the object to which the script is attached, right? It's in the scene, right? And it's the game manager. And then we go here, game manager, handle, submit button, right? So now when I click the button, we should get that debug log. Let's make sure that works like that. I don't have those on for some reason. All right, so it does, in fact, work, as you can see. All right. All right, so now we just need to, I'm going to enter text here, right? And that's just going to be a score. So I'm mocking up like the end of the game where you already have a score, right? And I'm just going to put a score in here, and if it's lower than the current best score, then we're going to replace the best score with it, right? And display that, right? All right. So now we're getting to the part where we actually have to store these scores, right? All right. Now what I'm going to do here is a little different than the way the book did it, right? It continuously accessed the player prefs every time it needed to pull that data out of them. I am going to basically, at the beginning, I'm going to initialize some global variables, and then at the end, I'm going to save those, right? All right, so what's the easiest way of doing that? I was going to have a separate class to save data, which sometimes you do, but I think to keep it simple, I'm going to just do it all in the game manager, right? So we're going to say public static best score. Integer. Right? You got to have an actual data type there. All right. Okay, when you do it this way, right, it's best to have, and this is, you'll see this is very common, right? Public void init game. Init functions initialize variables at the beginning of a game, at the beginning of a session, right? And you'll see them, they're very common in programming. It's very common practice. So what we're going to do is create a function that at the beginning of the session, we're going to load in the player prefs into our best score, right? And then we get a new best score, we'll save them out to the player prefs from there, right? All right, so initialize game, we're going to say game manager. Remember the static variables, you have to reference the class name you're that they're part of, right? Equals player prefs get int best score. Remember, these player prefs, you have to be very careful with the spelling, because if they're not right, then they don't work right. All right. Now, this may actually create an error if we don't have one there, so we're going to wait to see how that plays out, right? Go away. And now we should be able to say, let's see, best score text dot text equals game manager best score to string. And now we can, in our start function, we can say init game. Let's see what happens. I'm thinking this is going to give us an error, and then we'll fix it, right? Sometimes that's just the way you do it, because, all right. It didn't give me an error though. All right. So it initted to 0. All right. That's good. That's fine. Let's see. We don't actually want that though, do we? All right. So if we had our best score, since this is the lowest game thing, right? We don't want it to be 0, right? We need to, let's see. We need to determine if it's not set, right? Then we need to set it at something fairly high, right? So that we have something to beat, right? And we could say if player prefs has key, right? Has key checks to see if it already exists, right? And if it does, then we know something's there, right? In fact, we want to check for the not, right? If there's no key, right? When we say not has key, right? We want to check to see if there's not one. We want to set one at a fairly high number, right? And that's what we're going to do. All right, so we're going to say player prefs set int best score, and we'll just put it at 100, right? And we'll wrap this next line up in an else, right? Because if there is one, right, we want to get what the best score was, right? Right, and once we've done that, then we'll set the text to this. All right, so there shouldn't be a player pref there because we didn't set one before. Unless it set it automatically, and we'll see in a second. We might have to reset it, right? So let's see what happens. If this comes up 0, then we'll know it did. All right, so it wrote a player pref before when we got that 0. So we need to unwrite that, right? We're going to create a function, and it's good to have this, right? Clear prefs, right? And it's good to have this in the game because sometimes you may want to delete the data that's in the game, right? And having this function around, even if you don't call it all the time, it's good to have, right? So we're going to say player prefs delete all, right? And we're going to call that clear prefs right there. And we're only going to do this one time, right? Once we clear it, it should work again. And then we'll comment that out. All right, so if this works like I'm hoping it's going to work, it should show 100 now. And so let's do that. No, it does not. All right, so what did I do wrong? Right? So this is always fun when I get to check my own code. All right. All right, so I am going to put a debug log here just to see what's going on. All right, so here let me while I'm doing this, let me update our code over here. Right, so all right, so that should be updated now. All right. All right, so that's saved. Let me run this again. It says it doesn't have a key. Oh, I'm stupid. All right. The only place I'm setting the best score, this that I'm using down here, is in this, the else, right? So do I need the else at all? I don't think I do, in fact. So regardless of whether there's a key before it or not, right? I can come in here and I'm gonna just delete this entirely, right? So you see why that was, right? So I was only setting this, the game manager best score, when it wasn't when there wasn't a player pref, right? So make sure that's gonna work. Make sure I'm thinking right. Monday brain. All right, so now, all right. See, now we're talking, right? All right, so what we've done here, we've initted it. We've initialized the best score variable, right? And then we've displayed it. Now we just need to compare, right? What's in that input field with the best score, right? And if the new one's better, lower, then we will save that, right? All right. Before we do that, we're going to create another function, public void save game, right? And this is how mine is different than what we did last week, right? They call the player prefs directly all the time. This is just going to create a function that will save to player prefs when we need to, right? So what we're going to do here is say game manager. No, I'm doing that backwards, right? Player prefs set int best score game manager best score. Right. all that does is save it out to your player prefs, right? So when you initialize it the next time, it should pick that up, right? Here. All right, that clear? All right. So in our handle submit button, we need to, we'll say int current score equals, right? 1 second, I have a whiny dog I got to silence. All right. So current score equals score input text. Remember, we have to say parse. Remember that because the input field is text field, right? This isn't the safest way of doing this. A try parse would be better because if you input text in here, you're going to get an error. But this is kind of the quick and dirty way of doing it. Right? All right. So if current score is less than game manager best score, right? Then you could say game manager best score equals current score. Is that clear? Right? And we can say save game. And in our, is this the best place for that? Maybe. Yes, we'll go ahead and do that. If you had an actual game, I don't know, I'd put it in the save game, but for now, I'm going to put it right here. Right? So we're going to say best score text. Text equals game manager best score. What? Why did it do that? Oh, dot to string. All right. So now when we run this, stop it. All right. So it's 100. Let's put 95. Ta-da, all right. If I put 97, it shouldn't change. It does not. 50. Ta-da. All right. So, and I will update this code here. All right. So this doesn't show you how to do the number guessing game part of it, right? But this should give you a clear vision on how you can implement this into your game, right? If not, does anybody have questions about how this would work in your number guessing game? Or maybe you need to look at it a little longer and then come up with questions later on it. Questions about that at all?
No, not for me.
Okay. Anybody else? No questions from Katie. It's fairly. All right, cool. Jacob, you good? All right, cool. I think it's fairly straightforward, and hopefully it's clear. If not, certainly email me when you try to start implementing this into your number guessing game, right? But I think it's fairly straightforward. Well, anyway, that's that, right? So by Wednesday, try to get it into your number guessing game. If you have any issues, definitely show up Wednesday and we'll go over them. All right. Sorry about that. The perils of working from home. All right. Any questions about anything else? Brian, were you able to log out and log in?
No, it still didn't work yet. Oh, wait a minute. Can you hear me?
Yes.
Okay. No, it wouldn't log out, but the touchpad, for some reason, you kind of really have to push hard on it. So I'm going to try to hook up a mouse to it. That might maybe make it easier.
Okay.
But I'll work on that immediately after class, and if I have any questions, I'll email you. Or
okay. Yeah. I mean, I don't know. You should be able to log out. I don't know.
Yeah.
If not, look into the system preferences because maybe because you can set up your Apple ID in there, and it's kind of system wide then, and it may be that's what he did, and I don't know, but
Okay.
But you should be able to log out. I don't know why you wouldn't be able to, but if not, let me know.
Just quickly looking at it, like I said, I worked on it Friday and a little bit Saturday morning. Since Kaltura wasn't working anyways, I thought, well, I didn't want to get too frustrated with it, so I just kind of skimmed over it, but I'll really get into it today.
Gotcha. Yeah, Kaltura is still, as far as I know, I haven't checked the status today, but Kaltura has been having some serious issues, so we got to figure out some. You may have seen my QuickTime workaround, but I don't know if you've seen that yet. But
no, I haven't.
Yeah, I put a tutorial on how to use QuickTime to record your screen, and we might have to do that for now, actually, but because Kaltura is having some major issues on their end for some reason, and I'm not sure what to do about that because they kind of pushed us to use it, and now it's not working. So that's awesome. But yeah, just see if you can log out and let me know if you can. All right.
Okay. Yeah, I will do that.
Any other questions about anything? My question is, where is James? Or Brian Espinoza. I haven't seen him either. So that's concerning. Other than that, if there are no questions and you're good, you're free to go and we can get out of here because I might have to pick my daughter up in Wilson. All right. All right, so you're free to go, and I will log out after y'all. All right.
All right. Talk to you Wednesday.
Yep.